Sodium chloride, which is the name of common table salt. Once again, I'm going to find them both on the periodic table. Sodium right here is in the 1+ column, and chlorine or chloride is in this column right here. We've got metal and nonmetal, so we're dealing with ionic compounds, which means the atoms have charges. Now I want to figure out what the charges are. As I said before, Na is in the 1+ column, so an atom of sodium has a 1+ charge here. And then chloride is what we call chlorine when it has a charge, and chlorine lives in this column, so it has a 1- charge. So Cl 1-. Okay, so now I have one atom of sodium +1, and I have one atom of chloride -1. When I have an atom of both of these, does this positive and negative, does it balance out? It does. I don't need to add more of either one of these atoms. I'm totally set. So to write the chemical formula for sodium chloride, I want to say again how many of each I need for the charges to balance out. I'm just going to say NaCl. I don't put any numbers after them, because if I don't put a number, it means that I just have one of them. So I have one sodium and one chloride. Okay? You might be getting the hang of this. I want to try to convince you to watch this one last example because it's a tricky one that confuses a lot of people. Okay. Aluminum oxide. Once again, periodic table, aluminum here, oxygen here. Metal, nonmetal, it's ionic, which means charges are important. So aluminum is in the 3+ column. One atom or an ion of aluminum. An ion is just what we call an atom that has a charge. An ion of aluminum has a 3+ charge. And an atom of oxygen, oxide here, has a 2- charge. Al3+, O2-. Now I need to figure out how many of each of these atoms I need for the charges to balance out. And this example is a little bit trickier than the ones before. How are we going to be able to add atoms to get the same number of positive and negative charge? Let me give you a hint. We're going to start by adding another aluminum atom in here, or aluminum ion to be precise. So now I have 3+ here and 3+ here. Each aluminum atom has a charge of 3+. So I have a total of 6+. Now I can balance out the 6+ by adding more of the oxygen. I add one more oxygen, I have a total of 4-. And I add one more, I have a total of 6-. So this is how we balance out the charges in aluminum oxide, with 2 aluminum ions with 3+ each, total of 6+, and 3 oxygen ions with a total of 3 oxygen ions with a total of 2- each, which gives us -6. Now I'm going to write the chemical formula to show how many of each I need to have. That's going to be Al12 and oxygen 1, 2, 3. I have 2 aluminums and 3 oxygens. Okay, so here are the 2 mistakes people make. Let's assume that you're asked to write the chemical formula for lithium oxide, and you do this, you find out that you want to have 2 lithiums with 1+ each to balance out the charge on oxygen. Okay? Here is one mistake that people make. They say, okay, I have 2 lithiums and 1 oxygen, so I'll write Li2O1. They say, yeah, there's only 1 oxygen, so it can't hurt to just add the O1 here, can it? It can't hurt. It does hurt. It's just not right to do. You never want to put a 1 after an element. So Li2O1 is wrong. Instead, you want to write Li2O without any numbers after this, and this is the right way to do it. Here's another mistake that people often do. They don't remember to get rid of the charges when they write the chemical formula. So they end up writing something like Li plus 2 O2-, where the charges that were on the atoms here stay when they write the chemical formula. This also, unfortunately, is wrong. When you write the chemical formula, you want to get rid of all of the charges. So you just write again, Li2O. Make sure there aren't any charges in the chemical formula when you finally write it.